All right, geometry. So we're going to start chapter 9. Chapter 9 is all about transformations. So you have some experience with transformations in terms of slides, reflections, or flips and rotations, which are turns. We'll just go a little bit more in depth. The state of Ohio and the geometry standards want to really connect this to congruence and similarity. So we'll try our best to do that. But again, a lot of it's just going to be coordinate plane work. Okay, so 9.1 is on translations. So again, when you think of the word translation, just think of the word slide. So a translation is simply where you're going to take a figure and slide it on the coordinate plane. Okay, slide. So this section also introduces us to the generic idea. So a transformation is going to be a function or a mapping that results in the change in position, shape, or size of a figure. So if we look here, right, we have these dominoes, okay? So we're showing you the three uh, rigid motions, which you're talking about below here. So a flip, which is the word for a reflection, a slide, which is the word for a translation, and a turn, which is the word for rotation. And what's very important to understand here is that in these three instances, your domino changed position. Okay, it changed position, but it did not change shape or size. Okay, so just changed position. So be aware of that. Now, when you're doing these transformations, the technical term for the first figure or the original figure is the pre-image, and then the resulting figure is called the image. So again, I'll try my best. It's just pre-image and image. It is what it is. So again, rigid motions is very important here. So a transformation that preserves distance and angle measure is called a rigid motion. Rigid motions are these three ideas above here. A reflection, a translation, and a rotation are all rigid motions. And again, what it does is it makes sure that your pre-image and your image are congruent. So the pre-image is congruent to the image. Again, might change position, but the shape and size are remain intact. So notation, when we do a transformation, we are able to use this called prime notation with these apostrophes, okay? So again, typically your pre-image does not have the apostrophes, but then your image does. And again, this should be a capital J. I don't know why they're not capitalized, right? Our letters are capitalized. So triangle JKQ maps onto triangle J prime, K prime, Q prime. And of course, this is an example of a reflection if you are paying attention. Again, notice that you list the corresponding points of the pre-image and the image in order. Corresponding points in order, just as you do for congruent and similar figures. And again, we're going to make as much connection to that as we can going forward. Okay, so here's our definition of a translation. So a translation maps all points in a figure the same distance and in the same direction. So if you look here, triangle ABC is our pre-image. We are mapping it to triangle A prime, B prime, C prime. Notice that A, B, and C all slide this same distance and direction. Now on Delta Math, we're going to call this a vector. So we're going to use a vector to slide our figure. And again, notice it preserves distance and angle measure. So segment AC is congruent to segment A prime, C prime, just right here, right? They're the same length. Same thing with the angles. Angle C and angle C prime are the same measure. They're congruent to C prime. All right, so be aware of that. Okay. All right. Notice here this capital T. Sometimes that is your function for a translation. Okay. And again, I cannot emphasize enough that a translation is considered a rigid motion. Congruence, right? Rigid motion. So triangle ABC will be congruent to triangle A prime, B prime, C prime. Very, very, very important. Okay. All right, so most of this stuff is going to be on the coordinate plane. So if you take a look at this picture here, right, we are going to simply take each point in ABCD and we're going to translate it 4 units right and 2 units down. Okay. Well, that means that for each pair XY, you're going to do this. 4 units to the right means add 4 because you're going to the right, and 2 units down mean you're going to subtract 2. Now, you might see this function notation looking like this in a problem. So 4 comma -2 in these like, you know, weird triangular brackets, sort of. That's function notation for right 4 and down 2. But nonetheless, you just simply take each point and you do exactly as this graph is saying. You're going to go right 4 and down 2. And that's exactly what happens when you do that to every single point in your pre-image. You are going to get your image and they will stay congruent. Okay. So those are translations in a nutshell. Should not be too difficult for you. So I'm going to make another video covering some problems from Delta Math involving translations.